hey, I knew I was forgetting something, and I'm glad that someone was here to catch that. Uh, I was just saying, I'm glad to be back on stream for another short one after Saturday's brutal 2-hour stream. Did you get a chance to watch any of the video? I think I'm going to turn that into a blog post. I actually started, but it's going to take a while for me to flesh it out. Yeah, it was a really good one, and I'm actually going to touch on the outcome a little bit because I haven't, I still have, oops, I'm clicking on the wrong screen. I haven't merged any of the pull requests yet, so I can actually give you a, 5-minute rundown, if you want, of the different approaches that we talked about. But some other exciting news, if you haven't seen this on Twitter, but we finally have everything ported over to YouTube. So all of the stream recordings, they're still on Twitch, but now they're coordinated into a YouTube playlist in order as well. And I'm going to start convincing myself to do this every week, because uploading 7 YouTube videos at one time took my entire weekend up, and I don't want to do that again. So I'm going to try to do them every week now. And usually I come into these kind of prepared to do something a little more technical, but this week I, especially with Saturday's stream, I haven't had a chance to really put a lot of thought into it. So I thought I would tackle a little bit of tech debt that I've been thinking about, which is the fact that we don't really have a lot of documentation in the code base. And I'd like to clean that up because I want this to be a resource people can learn from, and so I think it would be good if the code is properly documented so people can help understand what's happening, and share some tips on writing good documentation, because some people are very opinionated about documentation on, we should never write code comments, and I don't think that that's a good approach. I think it's just that we need to learn to write good and helpful comments, and so we can talk about that. Seems like you are the only one in here so far, unless the Twitch view count is screwy. So I'll give you a quick run-through of Saturday's approach if you want, and I can show you a little bit about the differences between the two approaches. And let me do that over here in Android Studio. That's probably the quickest way. So I'll show you the do-it-yourself dependency injection PR first. So the goal for this, right, was we talked about dependency injection. At a minimum, we talked about how it's like passing things into a constructor. So we have this article list Viewmodel class that you've seen, and it takes in an article repository, and that's the dependency there. And then dependency injection is just the process of how do we supply that article repository. And there's a lot of different ways we can do that, and that's what the different dependency injection solutions we looked at do. So the first one, this do-it-yourself approach, well, let me take one brief step back and show you that, originally we had a Viewmodel factory inside the fragment that was, creating this Viewmodel factory and creating an instance of the article service and then passing that in. But at the end of the day, that stuff isn't really the view's responsibility. The article list fragment shouldn't care either where the articles come from. So all it really needs to know is, I need some Viewmodel factory because I need to give it to the Android system to create a Viewmodel, and that's it. So the way the do-it-yourself approach works is we have this extension function we'll look at in a second, but we get the context, then we call for some Viewmodel factory graph, and then we just say get article list Viewmodel factory, and then we can create one. So all of the dependency management for the article list Viewmodel factory, that exists outside the fragment now. And if we need to change anything about the base article repository for the app, we can go do that somewhere else. And the way it works in this case is we create our own base dependency graph, this study guide graph. And this is basically an interface that should expose how we collect all of the dependencies we need. And then we can break down those dependencies into subgraphs. So like here we have a data graph which exposes an article repository. And all of these graphs are interfaces, which allows us to easily swap out subgraphs, and will make it easy when we go to write unit tests to replace them with something else. And then we can give a base implementation, like here we can create a network data graph, which will give specifically the Android Essence article service that we've been using. But now, like I said, the view knows nothing about that, it's just specifically this working data graph that creates it for us. And then if we look at like the Viewmodel factory graph, that's a similar idea, but they work together. This Viewmodel factory graph accepts a data graph because now it can say my responsibilities are create a Viewmodel factory using some repository, but this also doesn't care what that repository is. It just needs to know that it needs one. And by writing all of these classes yourself, and then the way it hooks up, one more step. The way it hooks up is inside the application class. We expose the dependency graph in our application, and we give it like our base production instance. And then we have these helper functions that will give us like the subgraphs. We could say like require text app dot dependency graph. These are just helper methods, so we don't have to do that. So that's a really like lightning talk version. The benefits of it are just that we wrote all of the code ourselves. So even though in the fragment, like I can see I'm just requesting a Viewmodel factory graph, but if I want to really understand like where it's created, I can command click on this, and it'll actually take me right to this file where I can see the real way it's created. Does that make sense? That was, there's obviously a lot more to it, but that's the lightning talk version of the do-it-yourself approach. Awesome. I'm getting better at explaining that quickly, so that's cool. So the quick pros and cons of this do-it-yourself approach are basically that you manage all the code, which is cool, and you don't have any sort of black box like where things actually coming from. But the downfall is that it's more code for you to maintain, of course. And it doesn't really scale perfectly if you change, not so much if I want to swap out dependencies. Say, if I want to change the article repository, that's easy, I just change this. But like if I want to change this, instead of being like a single val, I want it to be like a factory method to create a new one every time, I have to change like this definition right here. And that has, that has a whole bunch of downstream cascading effects. So that's one of the downfalls. But then, cool, so if that was the quick overview, then we looked at Coin. And Coin is the one that I am in favor of merging into this project. And I'll talk a little bit about how it works. Let me sync these Gradle things real quick. But the way Coin works is it uses something called the service locator pattern, which is basically, let's look at an example. So in Coin, you would create something called a module. And a module, you define like how certain dependencies are created. So like here, we use lambda, which is like a singleton. We say this will create a singleton instance of our Android Essence retrofit API. And where that gets used is down here. Singleton instance of an article repository. And what we want to create is this Android Essence article service. And then right here we have API equals get. And that's all we use. We just use this one method called get. And what will happen then is Coin will say, oh, we're looking for an instance of the retrofit API. So I'm going to go look up in all of the modules that I've defined for Coin and try and find it. And the plus side of Coin is that my code here is very minimal, and I don't really again, I don't have to worry at all in this case about where that dependency comes from or how it's created. I just know I need to get this dependency. And this is where we get to, unlike the DIY approaches, this is kind of like black box magical. Like, where does it get it from? And how does it get it? And we don't have to think about any of that. Which in some ways, that's the point of a dependency injection framework. Is like, I don't care about that stuff, I just need to say that I need it. And I'll tell Coin how to create it, and Coin will handle the rest. The downfalls of this approach... Yeah, Coin is... The setup was very... So when I was looking at this versus like Dagger and Hilt, I got Coin working a lot faster. I had this up in under like 30 minutes to an hour. I got a working example. But the downfall to this approach is that this will always compile, but if I, at runtime, try to access this dependency, and I've never actually exposed it in Coin, I will get a runtime error. And that's different from Hilt, which we'll look at in a second. But you can create these modules, and these are very similar to, in the DIY example, like the dependency graphs. And then the way they get set up is also inside the application. We just call this start Coin method, and we tell Coin all of the modules we want to use, and it will just work. We have this Viewmodel module, which does some helpers around Viewmodel, which will like integrate with the architecture component and build like the Viewmodel factory for us. And so we actually have even less code inside of our fragment, wherever that is, because we don't need to reference a Viewmodel factory at all. We just call this by Viewmodel method, and Coin takes care of the rest. So that's really nice. I like it a lot, even though I'm not a big fan of all the different get calls that I know are going to be potential runtime errors, but otherwise I like it. And I know that Coin provides a test utility called check module. I haven't tried it out and got it working yet, but there is like a Coin test utility to validate like your modules, so you don't have a bunch of runtime errors. Does that make sense? Does that look cool before I show you the third example? Yes! Alright, so the next one was Hilt, which is the great buzzword around Dagger, and it's also Google's recommendation for dependency injection. And it works, the way it works is through a bunch of annotation processing. So anything that needs to use, let's start at the Viewmodel. With our Viewmodel, we can give it this @Viewmodel inject annotation on the constructor, which will basically tell Hilt like to create like, I don't know if the word is like bindings. See, I don't understand how Hilt works enough to talk about it, so watch me fumble. But this basically tells Hilt like, hey, we need to create something to supply the dependencies inside of this Viewmodel. And so Hilt is going to expect Hilt will expect that we tell it how to create an article repository. And the way we do that is also by creating some module. And so here we have that in this data module. And there's a lot of annotations here, so I'll walk through them. So we give it the module annotation, so Hilt knows this is a module that defines how to create some dependencies. We tell it what component to install it in, and this you can think of like scoping. So an activity retained component is a Viewmodel, and so what this means is that any dependencies in here should be scoped to a Viewmodel. They should like live as long as a Viewmodel lives. Viewmodel's created, we'll create these dependencies. When the Viewmodel is cleared, we want to clear out these dependencies. And then the binds annotation is specifically when we have an instance of an interface and we want to create like a specific implementation of it. So here we have an article repository, and I want to have that create an Android Essence article service. And there's some complicated stuff if I want 2 different kinds of article repositories. I might have to do that differently, but this is the short thing. And then this chain goes all the way down. So okay, Hilt now knows through this data module I need to create an article repository, which is going to be an Android Essence article service. But now Hilt also needs to know, how do I create an Android Essence article service? So we have another inject annotation on that constructor, and then it needs to know how to create the retrofit API. And that goes in this different Viewmodel, where unlike the binds method, we need to give it this provides annotation, which is because we're not defining like a one-to-one relationship between an interface and a class, we need to tell it like how to provide a specific instance of something. And so that's why this is actually a function, and not like an abstract method that will return like our default API. And similar things here, we define module, we install in, and because we were using, on the Viewmodel further up, because we were using this Viewmodel inject, that allows us to use an Android KTX component where we can do a similar thing in Coin and just say buy Viewmodels, and now this just works. So the difference between this and Coin is actually that validation at compile time. When we build the app is when Hilt is going to like run its processing, and if I expect to inject and I haven't specified the appropriate binds or provides method or annotation, I won't even be able to compile. It doesn't actually change app size, I don't think, because I do believe that Hilt actually looks up these dependencies at runtime, so that it doesn't need to like generate a bunch of code that you then ship with your app, but you do get that like compile time benefit of it. But as your app scales and as you add different types of dependencies, that can have an impact on build speed. So that's another downfall. But to me, the learning curve for this was just very complicated and not something I wanted to spend a lot of time doing personally. What are your thoughts on like that quick lightning round explanation? Do you think one of those is your favorite? Coin, easy, Hilt, recommended tooling. Yeah. I mean, what do you, and there's no right or wrong answer, everyone feels differently, but like, which of those would you weigh heavier? Like, would you be willing to take on the more complicated thing just because Google recommends it? Or do you think there's a certain amount where it becomes so complicated that it's not worth it, even if Google says it? Had to make sure I got Coke for this, by the way, just because I knew you were gonna mention it. I think my general opinion is like, if Google like that's what we should use, but if people are going to use this as a study guide. Interesting. I didn't think about it that way. Yeah, interesting point, and it would give me a chance to continue learning more about it. Yeah. Going into Saturday's stream, I was very much like against the idea of merging the Hilt PR, and then as I walked through the docs live, I became a lot more comfortable with it, and I had a couple people in chat to help me out when I got confused, and so I feel more comfortable about Hilt than I did before. But you're right, if this is supposed to be like a study guide for best practices, it should probably show off the best practices. I think that makes sense. I think we should do it. So what I'm gonna do then, I'm going to yeah, let's do it. We'll yeah. I added so now that I am a Twitch affiliate, you'll notice there's like the little Android Studio icon at the bottom. It'll say key stores, and like you earn points as you stick around and watch the stream. I made one in there where people can redeem their points to make me hydrate and drink some water, because I don't do enough of that. So you're right. I think that while I might use coin for my new project that I'm working on with my new company, Hilt is probably a good guide app if we want to show off best practices. So I say we go for it. I'm going PM. Instead of get app, we'll just change this bullet point to adding Hilt. Alright, let's do it. And by default, all of my branches are deleted, but I'm going to restore this just so people can still see the branches when they're curious. We'll do some cleanup. We will close these. Pull requests. We will close these. Awesome. And we will get checkout development. Cool. And I'm just going to make sure that I didn't break anything and all that. I'm going to run the app and just make sure that it still looks good. And then we'll talk about some documentation. Something that is off screen that I don't always show though is the coaster that I use on my desk is a GitHub Octocat. I don't know where Prince is. Well, he was cleaning up right before this. Probably ran off to do some other stuff. We made some incredible fish for dinner. We cook together. We order a lot of delivery, but we cook together a few times a week too, and we're getting pretty good at it. Tonight we made cod with peppers and rice, and I was just apparently really hungry, and I finished in like 6 minutes. It was really funny. I looked up and Prince was like halfway done, and my plate was empty. It was so good. Alright, so this is in. Let's talk about so let's talk about documentation, finally. I'm glad that I could do that rundown with you for Saturday's stream since you missed it. So, code documentation. What do I have to say about this? I think there's a couple different ways of documentation, because there's your actual like code documents like this, where you're writing like an explanation on top of a class. And there's also like, if you're writing a broader, like a tech spec documentation, like a README file, or some explanation about like an architecture or a decision, and we can probably talk a little bit about both and some of my tips for that, because I think technical writing is a really important skill to have as an engineer, but something we often overlook about how to do it right. Because sometimes you'll end up with, my article class already has like this long thing. But let's talk about like, you could write something like, I could say this is like, represents an article that the user can read. And then we can like, say that the property author name, and we could just say like the name of the author for this article, And like, you know, if we want to document everything, a link to this article. Like, we could write some docs like this. But what happens is, like, this is well-intentioned. We want to provide, like, an explanation to our future selves, to developers who come into our code base, to, like, understand what an article is. But as well-intentioned as it is, this documentation's not helpful. As a person coming in to read this, I probably know what an article is. An author name is very descriptive, and URL is also, like, pretty descriptive, right? So that's actually why I say, if you can't provide, like, a unique, helpful comment, and you're just gonna make something redundant, just get rid of it. Don't even include it. Because the reason some people will tell you not to write comments is because they can become, like, outdated, right? Like, I could change something. You get to see someone create Java docs for an Android app. Great, then we will do that. Because I have a lot of thoughts on this, and I'll share, if I can self-plug, I'll share a blog post I wrote on this last summer. But that's one thing I touch on, is this idea of redundant comments. Like, if you're just gonna write sort of in different words what the code already tells me, then I'd rather you just not write it. Hey, Brian. Because at a baseline, oh, Mohit, everyone's here now. At a baseline, the reason people don't like comments, right, is because they can become outdated. If I change my code, but I don't change the comment, then I could get in a really sticky scenario where I have, like, conflicting pieces of information. So if you code and that, you should favor that. Just for avoidance sake. You should try, even if you feel like it'll, you might, I have to document because I'm working on, like, there's some ways that we could take that a little further. So rather than writing something like, this represents an article that a user can read, we can say, like, an article is a text document that provides helpful learning resources for the reader, or something like that. That's what our articles are going to do. And so now this is, like, a little more descriptive about an article, right? Another thing we can do inside of our documentation is to provide an example. So we could say for author name, because that's very descriptive, we can say, like, oh, this is, whoops, we could say, like, this is the name of the person who wrote the article, and then we can put something like examples Adam, right? So now we have, like, oh, like, a clear example of the format of what an author name looks like. Wow, the view count is going up. I must have started too early today. Welcome, everyone. Today we're working on writing better documentation for the study guide app, because we've been slacking on that, and I think that we should catch up and provide some helpful notes for people. We can talk about tips for writing good documentation. So if you're forced to write documentation for a field that you think is redundant, the quickest way to spice it up a little bit is, like, just provide an example. This helps users, like, understand the format. What else was I gonna say? Like, here, even still for URL, I don't know how I could make this, like, again, I could say, like, this is the web address for this article, and then we could say, like, example androidessence.com / what the fuck, I don't know. We could put something like that. But there's actually a trick that I've been using in here that you might not have noticed, which is that concept of, like, if I change the code, my comments will break. And two ways we can combat that idea. The first one is the closer you can write your comments to the actual code, like the less likely that is to happen. So if I go in here and all of a sudden I want to say like, oh, we don't need this URL property anymore, well, I can remove it, but then I also know like, hey, maybe I should look at this documentation right here and see if it needs to be updated. The other thing that I did here was actually by using this at property annotation and the brackets around the field name, this creates a reference in the documentation to that particular field. So I can even like command click on this and it will take me to the field or the other class that I'm referencing. Like there's IDE integration with that. And if you take these docs and you actually generate like HTML files with them, which in Kotlin we do with a tool called Doka, these create hyperlinks. But additionally, with that IDE support, is like if I do something where I try to remove, sorry, can't see my keyboard, where I try to remove this URL field, now the IDE is actually going to give me a lint warning here and say it cannot resolve this symbol. So if I leverage those whenever I'm referring to a specific class or field, then the IDE will be there to tell me if my documentation is going out of date, if it's not right. So I highly, highly recommend, if you can, to create those references. And you even get you get all the IDE support. So if I want to refactor, we can see that it even changes the label up here. So that's my first tip around writing some documentation there around a class. So, whoops, oh god. Did I close that? Is that what I did? Meant to save it. So, let me know if you have any questions around that. That little at annotation is for a number of different things, so you can specify like property, param, so if you're dealing with a function, like this would be a param. In this case, it's actually both, right? This stuff here also serves as the constructor, so you can think of these both as a property and the class, but they're also like a constructor parameter. I don't actually know how this annotation changes the output like Doka HTML files, but maybe that's something we can look at later. You can document, oh god, all sorts of stuff. Samples, exceptions, author. C, this is like if I want to create a reference to something, like that's not like entirely accurate, like entirely relevant, but I could do something like, oh, I want you to also see article adapter because that's relevant. That's what this would do. And then inside the resulting documentation, it would tell me that that's like a relatable file. So those are some quick tips. What else can we document? So I thought about just going through and kind of documenting everything while giving tips along the way. So here's another one, actually. So we use this inline class inside the project, which was something that came up a few streams ago when we were doing some UI work, where we wanted to take some code and we needed to use the HTML class to convert it to a span so that it would show up on the UI right. And we made this inline class to take that string and get the HTML output for us. But this is, the reason I go to bring that up is at first I should actually write that. I should write all that out. This is an inline class that is a helper to convert some, we'll reference this input string and convert it to, to a span that can render some HTML to the UI. So there's all the documentation notes I already gave you. We'll write something, we'll reference stuff in the IDE, But if you're dealing with something that has external resources, maybe you copied code from Stack Overflow, or maybe you were working through like a bug in a library and you reported that bug, but you couldn't fix it yet. You should take a link to like their issue tracker or something and put it inside that documentation. One, it can provide more context to the future reader on like why you did something, like, oh, if this class seems out of place, it's because I copied it from Stack Overflow. Or to say, hey, this was a workaround that I implemented, but here's a link to, the third-party library where I reported this issue, and someone could check later, oh, has this been fixed? Let's update it. Or maybe you're using, like this, a language feature that people might not be really familiar with. So we could put a link to the inline classes documentation, and then someone can click on this and they can go learn more about inline classes if they haven't seen that before. So definitely, if you can provide comments to external resources, that can also help be like actual helpful documentation that gives the reader like something to work on or to follow up on. What else? Let's just kind of go through, and if I see something quick, I will go ahead and document this real quick. So, configures the visibility of a view to visible or gone based on the supplied condition. Cool. Document that real quick. Hey, look, that's an unnecessary comment. We're gonna go ahead and get rid of that. We could put some fluff on our main activity, but I don't really have anything to say here, honestly. Again, our application doesn't do anything. It just has the Hilt Android app annotation. And we could document stuff about Hilt, but that's what I think we might look at afterwards, is some actual like tech spec sort of documentation. Let's, for sake of covering everything, we'll say like this is the single activity in the application. It should be the user's main entry point into using the study guide. So that's just a little flair so we can have some documentation there, because that's my goal, to put it in there. It might make sense, again, documenting some of these classes can feel tedious because we know it really well and we think some of it's straightforward, but similar to Suhas's point on using Hilt, because we want this to be something people can learn from. Maybe someone stumbles upon this repo and they don't understand the point of main activity, so that small note I just made about this is the main entry point, that can provide some clarity. Let's say we could say something like the application class is where we should configure any application-wide dependencies or libraries. So like if we added Timber or something, we would do that here. And we can give examples, and we can say such as Dagger Hilt, hence the Hilt Android app annotation. So we provide like a little example there of what this is doing. So this one we can also do just a brief documentation on, again, because I don't fully understand it. We could say this is a Hilt module that defines how to create instances of any data-related dependencies in the application. So this is helpful for a new reader to understand what this does, but also for someone who maybe does understand Hilt can come in, and when they see this comment, they'll understand like the focus of this module is for data-related things. So if I'm making some dependency for an analytics tracker in the future, I might say, hey, this doesn't belong here. Let's look for like an analytics module or create one. And then this would be a good point where this is related to, thank you for the follow, Ben. This is related to our retrofit module because we depend on some of those. So we could put like the @c retrofit module here. So we can provide that link for the reader over into the other thing. And then here we can just say this HILT module is responsible for defining how we create any retrofit services used in the study guide application. Cool. We're cruising with this documentation. I love it. This is another good one I should have documented when I wrote it. This data response class. So this provides us a good example to like talk about one thing that comes up with code docs, which is the idea of like code should tell you what it's doing, comments should tell you why. So I could write a comment here and say like, this is a sealed class that represents two states, what do we want to call it? Two options for a data response, where the response is either successful or a failure. Like that's what we can say here. And this is like going back to that sort of gray area, like, is this comment helpful? Does this comment really provide anything different from what the code already provides? And ultimately, I would say the answer is no. Data response, while I don't necessarily know what that means or where it's used, is like descriptive. This is a response object, and I have two subclasses inside, either success or error. So like, oh, this does make sense. Like, I'm like, a data request is either successful or it errors, and I want a way to define both of those. But this doesn't tell me why. Like, so the reader might look at this and say like, well, why do we even have this class? So we can explain that. We can say like, by wrapping a response into this single type, we can provide a way for asynchronous streams to handle both success and failure scenarios without having to catch exceptions. This is because any exceptions will be wrapped inside an error class. So this provides like a more helpful explanation. We did this so that inside like our article repository, we can just consume a response. So rather than have to have like a try catch to worry about like, what if the call fails, I know that even if the call fails, I'm going to get back this type. So this comment helps explain that a little bit. And then we can actually show where this is used. So we could say @c article repository dot fetch articles. And we can go look, we can command click into this and now see this returns a data response. So that provides some explanation on why we added the data response class. I hope that makes sense. Let me know if you have questions about that idea. I think that is like a very important note that I may have overlooked. Is it's very easy for us to like rephrase what code is doing because we think like the code looks confusing, so let me try to write it in English. And that could be a little more helpful, but at the end of the day I want to understand like, well, why? Like, why do we need this class? So I hope that this change here answers that why. So I guess we'll just keep plugging along on documentation. So our interface represents any source of articles to be displayed. Yeah, let's change this. An article this is a data source for any number of articles. I guess I'm about to rewrite the same thing. Entities that should be shown to the user. Yeah, I guess I just rewrote the same thing in different words. Documentation's not perfect. I'm still getting better at it. We could document this method too. We could say like, this will make an asynchronous request. Yeah, our air conditioning is loud. I might have to remember to turn it off when I start to stream. Is it really buzzy, like distractingly? Or is it just like you notice it when it shuts off? Maybe I'll message Prince and see if he can turn the air off. Alright, I will remember to turn it off next time, but I will let him know so it doesn't turn back on. Okay, cool. Yeah, we'll turn it off. Thanks for that. I know people can hear it, but I didn't think it was like that noticeable. Okay, so where were we? We're documenting fetch articles. We say this will make an asynchronous request for articles, returning a data response that encapsulates both the success and failure scenarios. So that's documented. There's kind of this question on like, so here we have, oh, interesting. So here we have like our article service, and I could method again, but my typical feeling is like, why should I put documentation on this method if I've clearly documented the parent method in the interface? Now, if there's something specific that's different about this override than the parent, cool, we took care of the error. But in this case, I don't really think this implementation's doing anything different from the parent, so I'm going to leave this alone. But we can document this implementation just to say like, you know, this data source, what do I want to say? This networking service will request article entities from the Android Essence RSS feed. So this provides a lot of information here. Like, it's a networking service. It provides articles from this specific place. And then we can, I'm actually going to not document the API thing, because I would say that like in this case, I'm going to expect that the reader comes in and they like understand like retrofit. Or we could just say like, say, the retrofit, whoops. Let's say the retrofit instance that will make our networking requests. So similar comments on this one that I'd give. There is something really good here in this to-do statement, and I'm going to talk about that after. But let me keep slowly going through, see if there's anything else I want to document. Here's another example where we needed those use site targets to annotate both the field and the param. So I made a link to that in the Kotlin documentation because that was confusing. I could annotate all of these classes, but I don't really want to do that. I'm not going to document the... yeah, this is all specific to retrofit. We're not going to document any of that remote stuff right now, but maybe we can come back to it. We will come back to that to-do comment in a second. Yeah, so this class, this is our article adapter, which is a Recyclerview adapter. And this again comes into stuff that is like hard to write unique comments for, because most people coming in will understand what a Recyclerview adapter is. So we could say like this adapter class is responsible for taking a list of articles and binding them into a recycler view. So we could say that. That's fine. Again, this is more if someone comes in and they're not super familiar with Android, this is helpful to them. Click listener, we could say this will handle. Yeah, we got the, I got an emote. I love it. It's actually, I've had that Android for a while. Callbacks for click events on an article item. I've had that Androidify for a while. I actually have it as a sticker. The light glares on it. Yeah, no, that light is, hey, look at that. Yeah, so I have this as a sticker. It's also my GitHub profile picture. So click listener, we'll just throw a whole thing in here. This interface defines any click events that should be handled for an article list item. We'll even reference article here. Fragment. So here we show a quick explanation, just say like, this page is responsible for displaying a list of articles to the user. For the fragment, we can actually provide like a little more explanation at a high level of like what the fragment should be doing. So we should say the user should be able to interact with these articles by clicking on them, which will navigate away from our application into a web browser for reading the articles. So I think this is helpful because an Android developer coming in, like, we might know what a fragment is. So this is our chance to like not worry about the technical documentation, but just like, hey, here's what this page does. Especially if you're dealing with like a larger code base, like a production app that has a number of different features, this could be really helpful. Like, here's what this particular page does. And I actually just don't have to worry about documenting anything below here because I've really summed it up. We display some articles, we allow the user to click on them and navigate away. That's all handled in here. It's cool. We've got our view model, and we can say, we just say, this class is responsible for requesting articles from the article repository and mapping those requests into an article list view state, which is then exposed through our state live data. So that's, again, without worrying about like documenting all the methods below, I just threw in some high-level documentation about what this view model does. And again, using those brackets to reference things, so if I change the code, I don't have to worry about, hopefully if I change the code, I can get updated pretty quickly. This article view state, we can just say, this sealed class defines each possible state the user can be in when articles are being requested. Yeah, that's a fancy way of just saying like loading content error states. It's cool. That's some quick notes. I mean, that was mostly just me rattling off documentation, but I do hope the couple tips along the way, referencing fields, trying to use examples and documentation that feels redundant, leaving it out if it's truly redundant. Those are some big tips. I hope those were helpful. Does anyone have, I'm going to commit that real quick before I go back to to-do comments, because I have some suggestions on making those helpful. But does anyone have, ooh, we're on development. Let's switch to a different branch. What I'm trying to get out is while I do that and switch to another branch, does anyone have questions conceptually about writing documentation? Like, what are your any thoughts, concerns around documentation? Do you feel better about documentation after that, or do you still think documentation is dumb and you're never going to write it? Yeah, Mohit Brian has said a similar thing. The tests can also be viewed as documentation of the code, which is an interesting way to look at it. Version 4, number 18. While I'm doing this, I will share with you a self-plug real quick. There it is. This was a post I wrote about last summer. It was turned into a talk. I used a SpongeBob time card in my talk. I was very proud of that reference. Yeah, docs can be more useful in a library. Yeah, I think the reason we feel that way is like because we're writing them for someone else versus ourselves, where we can take less for granted about what people do or do not know, versus for yourself, like especially as a sole developer, or even if you're on a team of 2 to 3 people and you all work really well together and like that one other person reviewed the code, documentation could definitely feel a little more overwhelming. Which is why I, to repeat something I said in the very beginning that I think was missed, is like, if you find yourself writing documentation that is like redundant and a repeat of the code, and you're not doing a public library, just gut it. Because those redundant comments are just noise in the code base. They're more lines in the file, they're not actually helpful, and I think that's fine. What do I say in this post? I try to say that, like, think about comments from the point of view of, like, you don't want to write them. Like, if you find yourself writing a comment, ask yourself, like, do I need to? Can I change something to make it so I don't have to write this comment? Like, that's the question. Don't just say, like, I don't want to write comments, so I'm not going to. Because you might need to. It's just, like, if you find yourself, ask yourself, like, can I get rid of it? So I talk about that in this post. I show like, redundant comments, just get rid of them. Also the idea that like you could change your code to avoid a comment. So here's an example. Let me blow this up a little bit. Oh God, that took me back. What the heck happened? I went to Command Plus. Sorry, please hold. Because I really like this example. So this was totally something I have done before, is like we have this save data method and we write a comment here like, oh, this saves data to the database. And this is a well-intentioned comment, right? And that I'm like, oh, I want to provide more insight to the reader that like this doesn't just save data, it saves it to the database. But like really what we should do is we should just name the method save data to database. Like, that's what we should do. So the heading here is like, can you change your code to avoid needing the comment you felt you needed to write? Similarly, inline comments. So let's say we're working on like a finance tracker and we want to transfer money. And the way we do that is we create a withdrawal transaction and remove from the from account. And then we create a deposit into the to account. And like, that's all in one method, so we add these little lines to like separate that logic. And this is bad for other reasons in programming, is it breaks this like the idea of like a single responsibility. But we can change our code around to like put those then into descriptive methods and say, in order to transfer money, we need to withdraw money and then deposit money. and now this code is readable without the comments that were there before. So maybe I'll just skim over this blog post real quick because it will talk about things better than I could do in real time. Is like that's the first section of this, is like look for ways you can eliminate comments if possible by removing the redundant ones and changing your code around. But then what we end up with after we do those two steps is we end up at a place where like, okay, well now we have comments that we know we should write, so how do we make sure they're actually helpful to the reader? And there's a few different ways we can do that. So we talked earlier about like the comments tell you why. So there was a whole thing, I gave an example with like the data response class. Like the example here was like, I was dealing with this issue with the paging library where a paged list object is like an immutable thing, and we wanted to change some of the UI, like Recyclerview items locally, and the way we do that is like we were using epoxy, and so the way we do that is like keep a list of updated questions and then use an interceptor in epoxy to replace the updated questions, right? And so I had this field called updated questions, and then I had this other comment where I said a list of updated questions to be replaced on our list by an interceptor. Like this comment's actually not helpful. It may have felt like it when I was writing it. Again, a lot of comments are well-intentioned, but this is not helpful to the reader, right? Because it doesn't say why I'm keeping this separate list of questions. Why is it being used in an interceptor? And so to change this, I won't make you read this full, but it basically explains what I said. Is like, the page list is backed by an immutable list, and I can't change it. But I want to change it because I want to change the data locally. For that reason, we keep this list of questions that have been changed locally, and every time our epoxy list builds, we will reference this list and see if we need to override anything with our local, like, cached versions. So now I've taken this and I've made like an actual helpful comment that explains why I used a certain piece of code. So this is really important. Comments with examples, we talked about that earlier. So like if we're documenting stuff about a Pokemon and we're just writing text that is repeating the property names, we can at least, if we're doing like a public API or library, like we said earlier, we can provide examples. So the name is like Bulbasaur, Ivysaur, Venusaur. The number 001, 002. It's like a small flare, but it makes it just a little bit more helpful. And maybe this is actually helpful to someone who's like, well, is the number 1 or is it 001? Or like, here it's an int, so they're the same. But like, there's nuances about formatting could be helpful. I don't know if I put it in here, but like, if you have a method that like does some regex, right? No one can read regex. So what you should do in like the documentation is say like, here's an example of some things that pass this regex. Here's an example of some things that fail. Those could be really helpful examples that go in your documentation. What else can be helpful? Links to external resources. So we talked about that. If you copy code from Stack Overflow, like link to it. So here we implemented this non-swipeable view pager, which I think is obsolete now because I think View Pager 2 gives us the opportunity to disable swipes, but the original View Pager didn't do that. So there was this really popular Stack Overflow answer that gave a non-swipeable View Pager class, and you could just copy and paste it into your project. But I like posting that because it covers, putting that link in the documentation, because it covers 2 points for me. The first one is providing a little more context to say, hey, I didn't write this, and here's where I got it. But it says because of that, here's where you can go if this is a problem in the future to get more context, to report a bug, or to comment and say, hey, there's a bug in this answer. And then I talk about actionable comments, and this was the example I was going to give a second ago around the to-do comments. And this was a fun header to write because I think this makes people pause when they first hear it. Is like, what is an actionable comment, because a comment is just something I read. It's not something I take action on. But I think there's two types of comments that we can focus on actually being like actionable and give us something to do. So the first is to-do comments. Those come up because we're looking through our code, we're doing some things, and we see an opportunity to refactor or rewrite something, or we know we want to do something in the future. And so we write this to-do comment because we think, oh, I'm going to come back to this and I'm going to do this, right? But we never do that. We never do that. So I think there's two things you should do if you find yourself writing a to-do comment. The first one, just do it. But of course, sometimes that's not always possible. You're working on a large code change. So instead, link to your issue tracker. Take what you were about to do and go make a Jira ticket. Go make a GitHub issue and create that accountability and then link to it back in your project. So I'll actually break away real quick and show an example where I wanted to do that in the code base was inside this article service, where I show if anything in the feed item are null, if any of this is invalid, we should probably throw an error, but we handle this empty state instead. So let's go in here, let's create a new issue in GitHub, and we'll say handle unsupported Android Essence article responses. And say, we can say something here if the Android Essence API request is successful, but the data in the response is not properly formatted, then we should throw an error. So we can create this issue, copy the link up here, and now we can just go throw that at the end of this documentation. Actually, we'll go a line up. But why does that make a difference? Well, because it creates an extra level of accountability, because no one's hardly going through code looking for to-do statements. But we are in the real world having sprint planning meetings where we go through the backlog and look at things to work on. And so if we put it there, where we actually, whether it's Jira, whether it's GitHub issues, whether it's some Kanban board, if you take your to-do statements and convert them into actionable tasks, you create more accountability where you're more likely to come back and clean it up and then get rid of that to-do comment. But if you don't do that, and you didn't know this, and I never use this even though I know it exists, is at the bottom left here on Android Studio is a to-do tab, and it will find all of the to-do comments in your project. And so you can actually use the tooling to find and fix to-do comments, but I've been an Android developer for 5-ish years now, and I've still never used that tab. But maybe one of you will like that idea, and it'll prove me wrong. So that's what I mean about an actionable comment that we can do a little more with our to-do comments. And then deprecation comments, which doesn't come up often. The to-do tab is helpful. The deprecation comments are a good one. Again, as someone mentioned, if you're working on a library, where you might be deprecating something, or even in your own code base, is you might go in and you might throw the deprecated annotation on there and call it a day. But that's not enough, right? Because then I'm going to be the reader and I'm going to come in and I'm going to see that it's deprecated. I'm going to say, now what? What's the alternative? And this was a case actually where Android is really good about this. Sometimes. In this one case they were. But I found this coordinator layout class where they had the deprecated annotation, and then they said use attached behavior instead. And this is so helpful as a developer. If you need to deprecate something, fine. There's all sorts of reasons that we deprecate classes. But don't just put the deprecated annotation on there, provide an actionable comment that tells the user what it's been replaced by, give them their next steps on where to go after you've deprecated something. And I think we do see that a lot, so I'm not going to say that people are bad at this, but every once in a while you run into that, and it's like the most frustrating thing in the world to come across something that's deprecated and then have no insights into why, or at least not even why, but like, what do I use instead? And yeah, we'll spare the libraries that have caused me that pain, but it has happened. So again, like, that's an idea of an actionable comment to think about. And then I wrap this up, kind of go over that. So I'm gonna share this link in chat real quick. I'll put it in the resource notes. But yeah, I'm really happy about this. Is probably one of my like personal favorite pieces of content I've ever actually put out there, because I've always felt really strongly about it. And what sparked it, which I left the saltiness out of this for now, but there was an article that the Java programming language shared on Twitter last summer, and it was just titled "Stop Writing Code Comments," and I was just like, no. Like, comments have their problems, and I talk about that in the beginning, and I've said, like, if you have a risk that, like, your code could change and the comments won't, and like, so there's a risk there, but the solution to that risk isn't to just give up. The solution is, like, how do I write helpful, maintainable comments? And that's what I hope you were all able to pick up from this stream. I actually realized I've been streaming for about an hour now, so I think I'll leave it at the code comments. Next Wednesday we can do something more technical again, because I'm sure you all enjoy the coding streams a little more, but I would love some time to talk about more, like, I guess, like, technical tech spec documentation. I started a new job recently, and that has been something that I've had to do, is like documenting, like, our code base standards and documenting, like, some of our third-party library decisions. And, like, that doesn't go in code comments. That's in a separate, like, markdown file in the repo. I think it'd be fun to talk through my process there, with technical writing, or maybe any other writing workshop. I've blogged a lot, and so I'd love to share my ideas on, like, what makes a good blog post. But I think we'll stick to the code comments idea for now. So, any thoughts, questions? Did anyone learn something new? Like, what was something new that someone learned about code comments that you didn't know before this? It could be, like, I don't know, anything. Like, Brian called out the to-do tab. I suppose if no one's in a rush to sign off, I could try to, I don't know if I want to try and figure out the DACA thing. It's probably pretty quick, but why not? Let's try it. Just so we could see, like, what that would make. I think it's kind of quick to set up, the DACA stuff. You got inspired to doc more? That's great. I'm not using KTS. Alright, I'm gonna look into this and maybe I'll clean it up next time. But this tool, I'll link to it if you're curious. DACA is the documentation engine for Kotlin. So it will go through my project, take all of the files and the KDocs that I put on top of things, and it will then, like, make HTML files that I can click through that populate that documentation. I mean, it's good to document things. It's really helpful for newcomers, or even yourself in the future. Like we always say, write code for your future self in 6 months to come back and learn from. So I definitely think, like, if you do it right, if you stick to just these helpful, actionable comments, they're really helpful. And yeah, I love, like, just that. I can't say this enough. I love the IDE integration. So even if I'm in this class in the article service, like, I can see this article thing and I can click on it and it takes me an article and I can just, like, go down this rabbit hole, like, learning about different parts of the code base just by clicking through the documentation. So they can be really, really helpful. Adding GitHub issue link for. So I will I'll merge this PR after the stream, add those resources that I posted in there. While there are more of you here than were at the beginning, exciting news if you didn't see it on Twitter. All of the study guide streams are now on YouTube. Have this study guide Twitch playlist. It's in the project README. I'm going to go ahead and give it to you all right now as well. So definitely the videos will continue to be recorded on Twitch. So if you like coming back to Twitch and watching it, you can. Something like YouTube, though, I think it is better at, like, tracking your progress on a video if through, like, cookies and stuff. So you could check them out there as well. But yeah, that's really exciting, and I'll try to do that more often and not, like, wait every week. So if you are interested, you could also subscribe to be notified when they go up, but I'll just be a disclaimer. I'm happy to put them up here for, like, persistence sake, but I'm not trying to become a YouTuber, so if you don't subscribe, I won't be disappointed. But do follow me on Twitch if you're not, because I'm excited to keep doing this. So please follow, share it with your friends, come learn some stuff. If you have ideas for different types of streams outside of the study guide, let me know. I keep saying I'm going to do, like, a code review stream or some paired programming stream. I'll have to come up with a good paired programming stream, but no one has yet to be brave enough to, like, suggest some code they want me to review. But if someone wants to do that sometime, I'm happy to do that. So cool. Wanted to share a tool I've been using for documenting our customer-facing library. This is based on Docker, new Docker with column 1.4. It does include some of these features out of the box, but this totally helped us out creating. Cool. Thanks for that. I'm going to open that up real quick. Orchid. Interesting. So, interesting. I'll check this out after, and if I can get this running, I will share this in the resources for today's stream as well. Thanks for sharing this. Did you say this was... Oh, it's based on Docker. Okay, nice. Yeah, I think I saw something in another Slack group about the improvements in Docker 1.4 were a lot better. And that's because, like, the initial documentation engine was, like, someone referred to it almost like a hackathon project. It was, like, just whipped together at JetBrains, and it wasn't really intended to, like, be a production tool. But now, like, that more people are using it, I think they're trying to give it some more love and care. So, awesome. Any other questions, thoughts before we head out tonight? I really appreciate everyone coming by again. I will be not streaming this weekend, so we'll be back here again next Wednesday. Not sure what we'll work on yet. I have to plan that. When I started this endeavor, I planned about 4 or 5 streams ahead, and now I'm just kind of winging it.